collection. So first of all, we need to define statistics. So keep in mind that there are two words. One is statistics, plural, and the other one is statistic. They are not the same. This is the science, the topic, the mathematical topic. This is something else. This is a numerical summary based on a sample. So when we talk about statistics, we really mean the mathematical topic. And I will explain what that means, statistics. Statistic still can have an S at the end, but when it's singular, we're talking about numerical summary based on a sample, and we can talk about two or more numerical summaries based on a sample. So we can have the mean, we can have the standard deviation, and so on and so forth. And yes, we can use plural for more than one numerical summary based on a sample. But so careful, statistics, mathematical topic. So what does it mean? What are we doing when we study statistics? So statistic as a science deals with collecting data, organizing data. This is what lazy people do when they don't want to write the same word again. Summarize data. Of course, analyze data. And what are we doing with all this? We want to draw conclusions. We want to make decisions. We want to answer questions, research questions. What could be a research question? Does anyone would like to give an example of a research question?
How much hot dogs do you need for the amount of people that are coming?
Well, we really would like to see effect, right? So of effect of something on something else. So something like, does smoking create, trigger? Does it create or trigger? Is it the reason, if you want, for since I kept the create, I'll erase that. Does smoking create lung cancer? So we want to talk really about the goal here is variability in data. So that's the goal of statistics. We're looking at variability in the data. So we want to try to answer the question: will smoking, the number of packs of cigarettes per day, per week, depending on how you want to set it up, and the number of packs of cigarettes, will that create lung cancer? So what will be the number of packs of cigarettes? So we're talking about now variables in a study, variables. So number of packs and the result, lung cancer. So these two are related, and we believe they are related, or we just want to check whether they are related. So that's our research question. So what are the variables in this particular question? There are two variables. If you remember, whenever in mathematics we try to graph something, we say this is the independent variable, and we say that this is the dependent variable. Well, this is the independent, and it creates the response. This, by varying, or the variation of x, creates the response variable, variation in the response variable. So obviously one of these two will be the response variable, and this is the lung cancer, the y. So the number of packs of cigarettes is one variable, which is the independent, and lung cancer is the dependent. We call this the response variable. And this is the explanatory. This, the independent variable, is the explanatory variable. So we want to see if 2 packs per cigarette per day, or 3 packs per day, or whatever, will that trigger the response variable, which is the lung cancer. So we want to see if this is indeed triggering that. By varying this, we want to see if that changes in y. If there is no change, then there is no relationship.
Your camera went out.
Oh, yep. Thank you. Sorry. It's the plug is very, very fidgety for some reason. I don't know why. I probably have to look at it and see why it's doing that. Okay. Any questions so far? Okay. So in our little study, if the number of packs of cigarettes, or smoking, in other words, creates lung cancer, we have a population. What is the population? All smokers. I have no idea. I don't know the study, how many smokers are in our country. Out of 360 million, I don't know how many are smokers. But that is the population for us, not the entire 360 million. Just all smokers in the country. That's the population for our study. Can we get to all of them? No, we cannot. We cannot interview each and every smoker in the country, because they are probably still in the millions. We don't have the money. It's too expensive, and it's too time consuming. What are we going to do? So population, any population has notation, population size. Notation for population size is always uppercase N. So we cannot interview everybody. Too expensive, too time consuming. Population size is called N. Now we are going to collect a sample of N. Maybe just 1,000. Maybe 2,000, maybe 10,000, but just the sample that we can manage. And the notation for sample size is lowercase n.
Your camera went out again.
Ah, that is really annoying. Thank you for letting me know. Let me move my... Yeah, that's what happens every time I move. It's this plug here that I'm not sure why it's doing that all the time. Okay, I'm back, I think. Yeah, I just can't touch anything. Okay, so we collect a sample, which is a subset. The sample is a subset of the population. Okay. So one thing before we continue, statistics has two parts. One is called descriptive. And I think we have chapters 1 through 5. And the other one is called inferential. Descriptive statistics, inferential statistics. Descriptive is really looking at organizing, collecting data, organizing, summarizing. Inferential, remember we collect the sample size. We collect data on n, not on uppercase n, on lowercase n. So this is extremely important, the second part. What is the second part? Collecting data from n, we will make inferences about the entire population. So we have to be very careful when we collect this sample. It has to be random, it has to be well defined, and it has to be representative of the population of all smokers in the country, if that's what our study is all about. So the sample we collect has to be representative of the population. If I stand at the door at entrance to Walmart and I ask people, hey, are you, I don't know, Republican or Democrat? And then I conclude that 20% are one type and 80% are the other, it means nothing. Because people going into Walmart are not representative of the entire population of 360 million. They are not. So I cannot make any conclusions about 360 million people, the entire population, plus or minus, by creating a convenience sample. That was a convenience sample. It didn't cost me anything. I didn't study anything. I just observed people and I asked them. That doesn't mean anything. So in order to draw conclusions about a population, the sample has to be representative of the population. It has to be randomized and it has to be correctly collected. And this is about 6 to 12. So in chapters 1 through 5, we're going to talk about this. And then we're going to reach the point in which we have the information, it's summarized, organized, etc., and now we're ready to make conclusions, to make decisions about the population of whatever that is. In my example, is smokers. Okay. What is the process of statistics? Okay. And what do we get from a sample first, and what do we get from a population? So what is called parameter is a summary, numerical summary based on the population, of a population. Now back to that statistic, singular. This is the numerical summary. We wrote it before. Coming from the sample. As an example, for the mean of the sample will be X bar. Mean of the sample, what is that? The average. I add up 10 numbers and I divide by 10 and I get the average or the mean. Same thing. Average or mean. Of course, this is the notation for the statistic. It's coming from the sample. The notation, the same thing, but from representing the population average, is this Greek letter mu. Mu. This is the population mean. And this is called the parameter. We don't have it. We may never have it. We just hope that our sample is representative of the population, and when we determine X bar, X with the bar on it, with the mean of the sample, this is pretty close to the mean of the population, which is the parameter, which we do not have. So the statistic is X bar for when we talk about the mean. The parameter is numerical summary of the population, which we don't have, is mu, the population mean. Okay. Now the process of statistics. I don't want to touch my computer. I don't touch anything. I just don't. I hope that this is not gonna